Imagine that one of the most important factors in making our Earth habitable suddenly disappeared. Gone. What do you think would happen? Earth is nestled in the golden mean of the solar system, which allows for the presence of liquid water. Because of this, we have a temperate climate and changing seasons due to the tilt of the planet's axis of rotation, which promotes an even distribution of heat. This ideal location, at a distance of 150 million kilometers, 93 million miles from the Sun, protects us from extreme temperatures and solar radiation, making Earth suitable for a variety of life forms. Until recently, the Earth's inner core was thought to be rotating at the same speed as the planet as a whole. However, a study published in the journal Nature found that between 2009 and 2020, the rotation of the inner core slowed down and then may have changed direction. But what if gravity on Earth increased? Every step you took would feel like you were lifting tons of weight. Your feet would seem magnetized to the ground, making walking a true challenge. The air would become thick and viscous, making each breath feel like a struggle requiring superhero lungs. With the increased gravity, the oceans would begin to rage, causing extreme high tides, crashing down with renewed force and power. And if gravity suddenly decided to rest and became weaker, our world would turn into a scene from a comic book. Imagine walking down the street, floating effortlessly above the ground. People, like feathered heroes, could move in the air, freed from the chains of the Earth's gravity. But, even with such superpowers, we would have our own difficulties. It would be difficult to remain chained to the ground, and every step could be a little flight. And the wind? It could carry us like leaves into the sky. How about a world where the Earth's axis of rotation is constantly oscillating? Instead of the usual 4 seasons, we would have a ride of extreme temperatures and weather patterns. In the winter, it could get so cold that even the northern polar bears would say, "No thanks." In the summer, it could be so hot that the sand in the desert would turn to glass. Now think of the atmosphere as a great bar where oxygen is our endless cocktail and carbon dioxide is a treat for plants. They are both always at hand, ensuring our comfortable lives and nature thrives. Without this protective barrier, water would be unstable, turning to ice or evaporating into space. The atmosphere also works like sunglasses, protecting us from harsh ultraviolet light and allowing us to enjoy sunny days safely. Without an atmosphere, human life would be a cosmic nightmare. Imagine that the water in our body begins to escape violently due to lack of pressure, like water on a hot griddle. Our skin experiences an attack of radiation without the protective layer of the atmosphere. At night, our body is enveloped by the cosmic frost, and during the day, by unbearable heat. There is no oxygen, and each breath becomes more difficult, as if we were trying to breathe at altitude, where air is catastrophically scarce. And all this is accompanied by the threat of depressurization, when our body risks being destroyed by internal pressures. All these components proved critical in the early stages of the Earth's development, when the mystery of the origin of life began. But its mystery has yet to be conquered by scientists. We can launch ships to other planets, watch movies from anywhere on Earth, and even detonate king bombs. But how to cause a spark in a bunch of chemical elements that will turn them into at least the simplest single-celled bacterium is still a mystery to us. In terms of biology, we understand this process so-so, but in terms of history, we know quite a bit about the origin of life on Earth, even the approximate place where it happened. Officially, the oldest evidence found of life on Earth is fossils from Western Australia. There, in the Pilbara region, there are rare deposits of basalt from the very distant past. The apex basalts are estimated to be up to 3.8 billion years old. Inside them, 11 fossilized microbes are found at once, somewhere around 3.5 billion years old. It is almost unrealistic to find rocks from those times because of the many changes that have taken place. Volcanoes exploded, tectonic plates moved, and asteroids fell with enviable regularity. But perhaps in the hydrothermal springs of the belt, with the cutest name Nuuk in Canada, found microorganisms the age of which is tentatively 4.2 billion years. Now, the information is being verified, but most scientists agree that after the formation of the ocean on Earth, 4.41 billion years ago, life most likely appeared almost instantly. However, the question of why life originated in the ocean is related to the myth of the importance of water. In fact, life could have started on coastal areas as well. In the early Earth, about 2 billion years ago, the atmosphere was very different from today's atmosphere and contained many gases such as hydrogen, sulfide, and methane. The sky was dark brown, and ultraviolet radiation penetrated the atmosphere, making the surface dangerous for life. So life probably took off underwater, where it was safer. Scientists use the term LUCA, last universal common ancestor, to refer to the common ancestor of all living organisms on Earth. Understanding what LUCA was like when it appeared and which living organisms were its descendants is challenging due to the lack of direct evidence or fossils preserved for such a long time. Much more interesting is where LUCA and other first living organisms came from. It is one thing to know what they ate and where they lived, but to find out how exactly they appeared is a different level of challenge, the answer to which scientists are not even close. There are 2 global chairs to sit on. To be more precise, 3. But we will not touch the theories involving gods. The remaining 2 chairs are the chair of ridiculous chance and the chair of the laws of nature. We will try to explain them without RNA, DNA, and other complicated stuff. The first theory, ridiculous chance, states that life on Earth arose due to the coincidence of hundreds, if not thousands, of factors. The temperature in an underwater geyser jumped by the right fraction of a percent. A phosphorus molecule at the right angle crashed into nitrogen, somewhere carbon, oxygen, hydrogen, and calcium joined the equation to form the first cell with the ability to divide. And then, as they say, it just went from there. Asteroids, aliens, and other exotic theories actually belong to the same theory of chance. There are thousands of them, but the essence always boils down to the same thing. Either an asteroid from a planet where life miraculously originated, just as miraculously crashed into the Earth, or aliens miraculously chose our planet out of tens of thousands of similar ones. When thinking about these options, it is critical to remember what we said earlier about conditions on Earth. We had greenery, oxygen, and drinking water much later than life at the time of its inception. The Earth was not particularly different from its neighbors in the solar system. Moreover, there is every reason to believe that in some periods, the conditions for life in our modern understanding on Mars and Venus were much better than ours 2 or 3 million years ago. Both there and there flowed oceans, and the atmospheres of the planets were not particularly inferior to the Earth's. The fact that we are doing better now is partly a consequence of the work of life on Earth. After all, the same oxygen in the atmosphere at one time impacts through bacteria. In general, any of the scenarios involving asteroids and aliens, a coincidence of circumstances, is essentially random, for it was possible to populate other worlds. Paradoxically, but despite the absurdity of this option, it is in it that most of the inhabitants of the planet believe, mainly because of the lack of understanding that life does not necessarily resort conditions, as on Earth. Among scientists, in turn, another theory dominates: the theory of the fundamental laws of the universe. It doesn't require a trillion coincidences. According to this theory, the mechanism for the emergence of life is the same throughout the cosmos. We just haven't gotten to it yet. As a consequence, looking at Enceladus, a satellite of Saturn, Europa, a satellite of Jupiter, and other worlds with underground oceans, scientists have a 99% probability of claiming the presence of life, not because of faith, but because of a reluctance to think of Earth as something unique. The conditions on these celestial bodies are not particularly worse or better than those in which we once had life. The theory of cosmic equality, and it, unlike the theory of chance, can be easily tested. Someday scientists will surely fly to other planets and check what happens to life there. They will solve, perhaps, the main question in the history of science: The final and perhaps the main argument of this theory is that chemical reactions and physics are the same in the universe. Carbon dioxide behaves the same on Earth and on Mars. Water is abundant in the solar system, and there is less of it on Earth than on tiny Pluto. So why exactly should we be unique? This is already a question of philosophy, and I will leave it to you to discuss.